All right, so first part says, is this table proportional? Guys, you want to start on the side tomorrow on your paper that helps, the chapter 3 notes side. If you don't know which side that is, it's the side that says 3-1. This is chapter 3, lesson 1. So this talks you through pretty much the entire first page. It talks about linear. Linear if you're talking about a table, linear if the rate of change is constant. So we'd be looking at the numbers on the outside. So it's linear if there is a constant rate of change. For graphs, it's linear if the points make a straight line. Okay? For proportional, this should say table. Somehow it accidentally got deleted. Okay? Use the numbers inside the table, and we're looking for equal ratios. For a graph, it's proportional if it is a straight line and it goes through 0, 0. So this really talks through the entire first page. Tables and graphs. How to think through those. And then we have an example here with a table. So, like on this first one, proportional is the first question. Constant rate of change is the second. We did that. Proportional. Notice it's the numbers on the inside, y over x. So I did 20 over 2, 40 over 4, 60 over 6 on here. They were all equal, so I said yes, it is proportional. The rates are equal. Yes, I know it's kind of faded here, but you should still be able to read that. The rates are equal. Then for linear, these are the numbers on the outside. This is my change in y over change in x. So I looked, first time it changed by 20 as it changed by 2. Next time it changed by 20 as it changed by 2. So it was 20 over 2, which is 10. Notice when you write a rate of change, you put a label. It was 10 miles per gallon. It was changing 20 miles every time it changed 2 gallons. Okay? So this entire box is really helping with the front side. Is the table proportional here? Yes, it was, because when I did my y over x, y over x, y over x, 80 over 4, 120 over 6, 160 over 8, they were all equal to each other. Don't actually forget, once you do the work, to circle yes or no. The next one, does it have a constant rate of change? Again, this is the difference. Proportional was y over x, rate of change is change in y over change in x. So these are the numbers on the outside. It changed by $40 as it changed by 2 months. It changed by $40 as it changed by 2 months. Well, $40 every 2 months is really $20 per month. Make sure you have the labels here, guys. It's not enough to have $20. A rate of change has 2 labels. $20 per month. Any questions on that first one? Second one is doing the same thing. It's just a different table. So on this one, we look at first for proportional. Again, if you need to go back to it every single time, do it. Proportional is y over x. So 100 over 3, 125 over 4, 150 over 5. When I simplify, they are not equal, so that's a no. Okay? If this is a no, that doesn't guarantee the next one will be no. You have to actually do the work. So the next one is constant rate of change, or linear. Once again, linear is change in y over change in x. These are the numbers in the outside. So it went up by $25 as it went up by 1 month. Up by $25 as it went up by 1 month. So when I look at that, that's $25 per month. Okay? If this was a no, you had to explain why. Make sure you're paying attention to that. If it's a yes, tell me what the constant rate of change is. If it's a no, make sure you're actually writing out why is it a no. Are there any questions on the first 2 problems? By the way, in case at any point, guys, I am talking so much and it would be easier for you to just listen to me and not worry about writing things down, the answers for all of this is going to be posted on Google Classroom. So if at any point you're like, nope, I just need to focus on what Mrs. Lumley's saying, just listen to me. Don't worry about writing it down because you can just always pull it up on Google Classroom tonight. Okay? The next part, same thing, same questions, it's just now it's a graph. So again, don't forget right here, it says graphs for linear, it's going to be a straight line. Graphs for proportional will be a straight line and through 0, 0. So like this one, asked if the graph was proportional. Grab your straight edge and see if it makes a straight line through the origin. Now I'll be honest, I had some people do this and they made a line and the line was slightly off of the origin, and so I saw them say no. I'm not going to give you one that's close, but just slightly off of the origin. That's probably just user error. Okay, it's going to be obvious if it's not going through the origin, but it's a straight line. Okay, it will be obvious, I promise. So yes, this is proportional. It's a straight line through the origin. Don't forget to explain. Then, is it linear? Well, guys, if it's proportional, proportional means straight line through the origin. So if it's a yes here, it absolutely has to be a yes here that it's a straight line. If it's a yes, it wants the constant rate of change. So I said here it went up by 50, it went over by 1. Okay, it's how it's changing. This one it went up by 100, over by 2. Either way, when I simplify, that's 50. Make sure you put a label on. It's $50 every hour it's changing. Up $50 over 1 hour, up $50 over 1 hour, up $50 over 1 hour, up $50 over 1 hour. Okay? On this one, if I would use my straight edge to try to connect them, it's not going to be a straight line. So it's not proportional. I can't say it won't go through the origin, but I can say it's not a straight line. Okay? You could say it's not a straight line and through the origin, but just saying it's not through the origin, well, we don't really know that for certain. Okay? It actually looks like there's a point there that would be through the origin. It looks like there is a point right there. Okay? So the next one, this makes this really easy to answer, except don't put the exact same thing. If it says, is the graph linear, you're saying, is the graph a straight line? If you put no, don't put your reasoning as, it's not a straight line. Tell me why is this one not a straight line? You could say there's no constant rate of change. You could say the points are moving differently from one point to the next. You can say that, I'm trying to think from the quiz, there were a lot of different ways of wording it that people did a nice job with. The rise over run was not the same each time. Anything that means they're not moving the same from one point to the next, the change in y over change in x is not equal, that's what I'm looking for. Okay? So all we've talked about is the first box here. The next stuff is going into slope. That means now we're getting into the second box. Yes, sir?
So we know in tests they'll go like for each page it'll go.
It's not quite each page, no. And you're going to even see that throughout here, because otherwise this would be 8 pages, and it's not quite 8 pages on the test. But it does go exactly in order, okay? So once you're done with this box, you will be moving over to this box, okay? And guys, this, I will be flabbergasted if you miss this, because they're literally right here in this box. It says rise over run. It says vertical over horizontal. It says y2 minus y1 over x2 minus x1. If you miss that, I might have gray hairs the next day. Like, that would be ridiculous if we're missing that one when I'm giving you this paper and they're all right there. Okay, you're just copying it down pretty much. Now, if you remember it, great. You don't even have to look at your paper. But if you don't, it's there to help you. Okay? Once you have these in, this really kind of puts this for the rest of the page, kind of tells you what to do. Like this one says, find the slope of the mountain that goes up. Up is vertical. 200 feet for every horizontal, that's the bottom, change of 750 feet. So 200 over 750, that simplifies to 4 over 15. Pay attention to the words up, down. Remember on our quiz we had ascends and descends. Okay, remember if it's going down for a rise, that will be a negative number. Okay. The next one is rise over run that we are using. And again, right here it says rise over run, and it shows on the graph That means we're doing how far we're moving up and down over how far we're moving left and right. Okay, the big part is making sure you're getting the positives and negatives. So my slope triangle from this point to this point, which on these two problems, guys, on the quiz, they will give you the points. You don't have to go searching for them. Okay, so these 2 points, I went down 4, right 4. Down 4 is negative 4, right 4 is positive 4. Now, the one thing that I've caught some people doing before is they go 1, 2, 3. No. Don't do that. Put your pencil down at the point, and then once you move, that's 1, 2, 3, 4. Okay? And it does say to simplify, so if you leave it that way, I would have to take half a point off. It should be -1 when you simplify. On the next one, my rise, I go up 5, so that's +5, and right 3, that's +3. We do not change it to a mixed number. We do not change slope to a decimal, so it would just be 5/3. Bless you. Any questions so far? Okay. We made the table part for the slope really big on here because honestly, that was part that a lot of people missed on the quiz. So when we're looking at this for slope, notice we're still in the slope category here. It has the names at the top of each one of what we're talking about. This is still slope. So it's how it's changing. It's really just this part right here. It's really just rate of change. So my change in y was -2, my change in y was -2, and my change in x was 3, and my change in x was 3. So -2/3. Make sure you do the right one on the top. That means a slope of -2/3. When you look at this, my change in y was 2, then 4, then 2. Yes, it was different, but if we look at the top, it was 2, then 4, then 2. Some of you, I don't know why, we're not getting the right number between -3 and 1. If you need to, use the number line up on my wall. Okay? So 2 divided by 2 is 1. 4 divided by 4 is 1. 2 divided by 2 is 1. My slope is just 1. Okay, make sure you're putting the correct numbers on the top tomorrow. And then the last thing is slope between 2 points. And right here, we put it right under the formula here, y2 minus y1 over x2 minus x1. And we gave you an example right here. So y2 is 6, y1 is -1, so 6 minus -1. x2 is -3, x1 is 5, so -3 minus 5. I found my numbers, and remember, if the negative's on the bottom and there's no negative on the top, there's just one negative, we usually always put it on the top. Calculators do not understand it being at the bottom of a fraction. So -7/8. Okay? Simplify if you need to. So if we look at this, y2 minus y1, -10 minus 5, x2 minus x1, -2 minus -7. That gave me -15 over 5. That simplifies just to -3. On 10, y2 minus y1 over x2 minus x1. 6 minus 3 is 3. 1 minus 6 is -5. So I really just wrote it as -3 over 5. I just moved where that negative was. Are there any questions on that one? Any questions so far on where to find things on your paper, your help paper? Okay, we're done with slope. That means we're moving down to 3-3. Okay. Anytime it says varies directly, we're looking at this section. Varies directly. Remember, that means it's a direct variation. Direct variation is just a fancy word for proportional. Proportional just means we're doing y over x. Okay? So, in this case, we're doing our y over x, and specifically on this, it says on a graph, find one point and do y over x. Remember, you don't need to do multiple points because varies directly means it's proportional. That means all of my y over x will all be equal no matter what point I pick. So I just picked a point I could clearly read, and it was 400 over 4. You might have picked 200 over 2. You might have picked 600 over 6, okay? Whatever your point is, you mark it, tell me what your numbers are, and when you simplify, make sure you label. So don't just have 100. It should be $100 per car. Okay? Yes, sir.
I put for every 2 cars Jim sells, he earns $200 net worth, or do we put that?
So the only thing with that is it does say how much does Jim earn per car. So it would be great if you simplified it. I don't care if you put it in a sentence form like that, but it would be great if it was for 1 car. So how much did he earn for 1 car? Does that make sense?
Yeah.
Okay, so like honestly on that I'd probably take like half a point off, okay? It's still good, but it didn't quite answer exactly how it was asked, okay? The next one, we're going off of this part to help us in a story problem. Remember, it's always y varies directly with x. So in a story problem, look for where it says varies directly and use that sentence to tell me what my y and what my x is. All right? So in this case, 5 friends bought concert tickets for $168.75. Do not use that sentence. That sentence doesn't say varies directly. I had some people doing that, and then they thought the 5 was the first number and this was the second number, and they had them backwards then. Don't do that. So it says assume the amount of money, that's going to be my y because it's before varies directly with the number of tickets purchased. So that's going to be my x. So I have money over tickets. So my money was $168.75. My tickets was 5 because there were 5 friends going. And that was $33.75. I had someone the other day say, but Mrs. Lumley, that's a decimal. That's all right. Okay, in this case, it can be a decimal in this. You can keep it as a fraction if you want in this. We just don't usually put mixed numbers into an equation, okay? From there, I went through and solved. So make sure it's in equation form. Y equals that kx. And it says that right here. You're doing y equals kx. So you find your k value, then you write your equation, y equals kx. Then you plug it into wherever. So 8 was the tickets, that's my x value. So $33.75 times 8 is $220. Make sure you label that. Or yes, $270, sorry. Okay. On the next one, it's the same stuff, it's just not a story problem. And we actually have an example on here of that. So we have my y was -12, my x was 4. That's k is equal to -3. So my equation is y equals -3x. Then if it said x equals -5, plug that in for x. And I would get 15. So here, y was -7 when x was 14. When I simplify, that's -1/2. If you had -0.5, that's the same thing. So y equals -1/2, or again, -0.5. X is your equation. In the equations, I have to have the y and the x there. I need both of them. Okay? Then it says, when x is 13, what's y? So I plug 13 in for here. Honestly, guys, I do not care how you write your answer on this. It's not in an equation. So give me a mixed number, a decimal, an improper fraction. I don't care. They all meant the same thing. On the next one, y is 18, x is 6. So 18 divided by 6 gives me a +3. So the equation is y equals k3x. The second part, don't plug this in the wrong spots. 27 is my y value. So I plugged it in and I have to solve. Divide by 3 on both sides and I get x is equal to 9. Do not accidentally assume that everything gets plugged in for x. Okay? Are there any questions on that page? Or so far, I guess I should say, because that's everything from this box. No? No questions? Okay, the next part, guys, mine is now off of yours a little bit, so like I'm flipping my page, but you are not, okay? So don't flip your page yet. The next one is 3, 4. Now I'm writing equations in slope-intercept form. So it gives you, that is y equals mx plus b. M is my slope, b is my y-intercept. And so it tells you, if you're looking at an equation like this, this is how you tell where my m and b is. Remember, m is my coefficient, b is my constant. So looking here, M is my coefficient, B is my constant. M is my coefficient, B is my constant. If you get one that is not in y equals mx plus b form, they gave you an example here, and if you paid attention, it's the exact same example. This should have been very easy to do. Okay, so you have to move this to the other side. When you do, this would cancel out. And negative 5x and 9 are not like terms, so you can't put them together. But really, you don't even have to go any farther than this. Negative 5 is my coefficient. 9 is my constant. Okay, so that's what you have here on this one. The next one's just going the opposite way. They gave you your m, they gave you your b, just like you had to find here. Now you have to write the equation. This is y equals negative 1/3 x plus 8. Y equals negative 3x plus 14. Those should be easy points. You don't want to be missing those. Okay? Go ahead and flip the page if you're ready. Any questions? Okay. The next one's graphing here. And again, this is still the same box. It's just below it. For graphing, y equals mx plus b. Remember, m is your slope. That's my move. Y-intercept is my b value. That's where I begin. Remember, you start your point on the y-axis. Even shows you y-axis goes straight up and down. Okay, so begin on your y-axis, then do your move, your rise over run for your movements. So on this one, it tells me to begin at negative 4, and then it says my slope is 5. So up 5, right 1, up 5, right 1. Turn it into a fraction if you need to. And then make your line. On the next one, my begin is at positive 4, so on my y-axis, I go to 4. And then my slope is negative 2 over 3. Negative 2 means down 2 for my rise. Run is positive 3, right 3. Down 2, right 3. The opposite would be up 2, left 3. Up 2, left 3. Any questions on those two? This is the only ones, guys, that it goes slightly out of order. Okay? I know your next problems are the x and y intercepts. Okay? But I'm going to go down to the bottom here, that 24 and 25, because those are the ones that are just the opposite of what we just did. So it's kind of working back from this. Okay, where did we begin? Plug that in for your B. How did we move? Plug that in for your M. Okay, so I'm going to jump down to these. Mine don't have the lines, but it's the same thing. Okay, so on this one, my begin was at positive 2. Do you guys see where I'm talking about? Yes? You should be looking at 24 and 25. I know my numbers are different. Look at your 24 and 25 problems, okay? So when you're doing this, my begin was at positive 2, and I went up 2, right 4. Or you could have said you went up 1, right 2. Or you could have said you went up 3, right 6. Doesn't really matter. They all equal 1/2 when you simplify. So y equals my m of 1/2, x, plus 2, which was my b value. On this one, my begin is at negative 1, and then I went down 3, right 4. So my slope was negative 3/4. So y equals negative 3/4 x minus 1. Are there any questions on those two? Okay. So just so you know, it's going to be the same thing on your test, that these two, and then if you skip this part, these two kind of come from the same box. Once you go to this section then, guys, the x and the y intercept, that's when you're going to take that notes paper and flip it over. Where did I just put my notes paper? Here. So now we have used everything on the front side. Now we go to the back side, and everything else is going to be from this side. Okay? So when we are looking at this, okay, and don't pay attention to my numbers. One year we had to skip this, so I took it out, and then so my numbers are off of your guys'. So don't quite pay attention to these. Okay? Actually, yours might be the same as those two. So when we look at our x and y intercept, it has a really good example on here. It says to find the x-intercept, we keep x and we make y 0. So x-intercept, we make y 0. 4x plus 2 times 0 equals 10. We wrote that out and we do the math. 2 times 0 is 0. So I get 4x equals 10 and you solve. That means you graph that on the x-axis. On the other one, we plug in x for 0. So 4 times 0 plus 2y. That would be 2y equals 10. Divide by 2 on both sides, you get 5. Graph that on the y-axis, okay? So when you're looking at this, we did the same thing here. I made it 0 equals 1/2 x minus 2. Add 2 to both sides. Divide by that coefficient on both sides, and you get x is equal to 4. So on my x-axis, I went to the right 4. On this one, I plug 0 in for x. Y equals 1/2 times 0 minus 2. Well, 1/2 times 0 is 0. 0 minus 2 is just negative 2. So I went down to negative 2. Okay. On the next one, 3x minus 4 times 0 equals 12. So I know 4 times 0 is 0. 3x minus 0 is just 3x. I divide by 3 on both sides, I get x equals to 4. Same spot as on the last one. On this one, 3 times 0 minus 4y equals 12. On this one, guys, you have to be very careful to keep that sign with it, or it will be wrong. You should be dividing by a negative 4 on both sides to get negative 3. So you should be going down 3 and then make your line. Are there any questions on 22 and 23? Are you sure? At this point, I only have about 10 minutes, and we have about 12 problems to get through, so I'm going to have to talk a little bit quicker. Let me know if you need me to slow down for something. Okay? Go ahead and flip your page. You should be looking at this at this point. Okay? When you are looking at this, guys, if I'm going to tell you to use your paper, your help paper on anything, it's going to be this. This is the top right section, and it tells you how to write linear equations when giving a point and slope or 2 points. These are the ones, guys, that it's very hard to remember all of these steps because there's a lot to it. So you do not have time to use this help paper on every single problem. These are the problems I'm suggesting to use it on. Okay, don't try to memorize all of this. If you got it, great. But don't waste your time memorizing it when you have a good example here. Okay? If you actually paid attention, did you notice that this example was the exact one I asked you to do? And this example here was the exact one I asked you to do? If you use the help page, you didn't even have to do any work for it. They were right there. Okay? So when you look at this, it's a matter of knowing this is m, this is x, this is y. And it even shows you that right here. You have your y equals mx plus b. Plug in your y, plug in your m, plug in your x, and solve. 3/4 times 0 is 0. So I get b is negative 7. So my equation is y equals that m that I had, x, and then that b that I had. Y equals 3/4 x minus 7. Next one is the same work. So I plug in my y, I plug in my m, I plug in my x. Negative 2 times 3 is negative 6. Add 6 on both sides and I get b is equal to 11. So y equals negative 2 that they gave me, x, plus 11 that I found. Okay? Again, this would be a section that if you just need to watch and you don't have time to write things down, this will be posted on Google Classroom. Just watch and make sure you understand what I'm talking through here. On the next one, it's the same work except now we have to find our slope first, which they show you that here. They show you have to do y2 minus y1 over x2 minus x1 first. So I did 11 minus negative 4 over 2 minus negative 1. That was 15 divided by 3, which is 5. Once I have my slope, it's the same as the thing above. Use my slope, pick one of the points. This was where I'd suggest you use a highlighter so you know which x and y you want to use. I picked this one. So my y was 11, my x was 2, my m was 5. 5 times 2 is 10. So I subtract 10 on both sides and I get a b value of 1. So y equals 5x plus 1. Okay? That was this one right here. On the next one, I did 0 minus negative 6 over negative 6 minus 3, and I got 6 over negative 9. That's negative 2/3. I picked the second point. So when I plugged it in, I had 0 for y, I had my m of negative 2/3, and I had x was negative 6. Negative 2/3 times negative 6 is 4. I subtract 4 on both sides, and I get b is 4. So y equals negative 2/3 x minus 4. This was my m, this was my b. Guys, usually this is where the most points are missed on the test. Are there any questions from this section? Okay. The next part comes from this, solving systems of equations. So it tells you, make sure you begin on each equation, make sure you move, then draw your line using a straight edge, see where they cross. Okay, where they cross is x and y for your answer. So if you look at the first set, on this one, my begin is at negative 1. So on my y-axis, it was negative 1. My slope was 3. That's 3 over 1. Rise 3, run 1. Rise 3, run 1. On this one, my begin was at 4. My slope was a negative number. This means this line should be going down. So negative 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1, all the way across. My point of intersection was right here. Do your x-axis number first, then your y-axis. So this was 1, 2 for my solution. Don't forget you can plug these in to see if it actually works. It should plug in and make it sense or make it true for both of them. Number 29. If there's nothing at the end, that means my begin is 0. It starts at the origin. My slope was 3. That's 3 over 1. Up 3, right 1. Up 3, right 1. Or down 3, left 1. On this one, my begin was at 4. So I went on to my y-axis at positive 4. My slope was 1. Up 1, right 1. Up 1, right 1. They crossed at 2, 6. So my ordered pair was 2, 6. The next set. My begin was negative 2, my slope was negative 1. So I began at negative 2 on the y-axis, down 1, right 1, down 1, right 1, down 1, right 1. Here I did not have a plus anything, so that's really plus 0. It begins at the origin. If there was no coefficient in front, that's really a 1. So up 1, right 1, up 1, right 1. That meant this was a negative 1 for my solution. On 33, I didn't end up giving you this because I don't give you one that difficult on the test, so I switched it out for you on your review. You both had different points to start at, 5 and negative 2, but since the slopes were the same, they are moving the same every time. That means they will never touch. They are parallel. That is a no solution. No solution. If those are okay, go ahead and flip to the last page. Okay, the last page comes from right here. This is the very last box. Chapter 3, Lesson 8. It talks you through things, and then it gives you 2 good examples of what it should be looking like. Okay? So like on mine, I used highlighters. You don't have to. Notice here it was just circling what was going to go in for the other one. So like here, I'm plugging 3 in for y. That means I'm going to read this. 3 equals negative 5x minus 6. Once I have it written out, I add 6 to both sides, divide by negative 5 on both sides, and I get x is negative 1.8. We write this as an ordered pair. Notice it says that here, right answer as an ordered pair, x, y. This one, they were nice. They gave us the y value. We didn't have to plug it back in. They said y is equal to 3, so I just brought that down for my y value. Negative 1.8, positive 3. Okay. On the next one, I was going to plug in 3x plus 8 for my top y value. So this is going to read 3x plus 8 equals 9x minus 4. So this is what I have. There's multiple ways to do this problem. So if you didn't move the 4 first, that's totally fine. We could still get the same answers. I did the opposite. Negative 4 meant add 4. So I got 8 plus 4 is 12. Then I moved my x's to the same side, so subtract 3x since this was positive. 9 minus 3x is 6x. Now that I have all my x's on one side, all my constants on the other, I divide. Divide by 6 and I got 2. So I put my 2 down for my x value and plugged it back in. 3 times 2 is 6, plus 8 gave me a y value of 14. So 214. Once again, you can plug them back into both equations to see if they work. 9 times 2 is 18, minus 4 would be 14, so that works. Any questions on the first two? If you look at 34 here, I am plugging in 4x minus 3 in for y, so we write that 7x minus 2, and then we have to use parentheses here, guys. This has to go in parentheses. 4x minus 3 equals 5. So once it's in parentheses, I have to distribute what's in front. Pay attention to this. This is a negative 2. So bring down my 7x. Negative 2 times 4x is negative 8x. Stay focused for me, guys. We don't have much longer. Negative 2 times negative 3 is a positive 6. Okay. You could combine like terms right away. I'm assuming that's what most of you did, or you could move this over. 7x minus 8x is a negative 1x. If I subtract 6 over 5 minus 6 is a negative 1. At that point, you divide by negative 1 on both sides and you get x equals 1. So I brought that down. And then I plugged it back in. 4 times 1 is 4. Minus 3 gave me negative 1 here. Or I'm sorry, positive 1 here. So it's really 1, 1. Okay. Once again, if you were using the help paper, the last problem here should have been very easy. This was that exact problem. So it gives another example of plugging it in and having to distribute. This time it was a positive 7 they were distributing. Combine your like terms, move the constants to the same side, divide out. Once you have your x, you plug it back in and write your answer as negative 1, 2 on that one. Are there any questions? Anybody have any questions on how to use this help paper on their test? Okay, then you may pack up.